Hi guys, welcome to your watershed and water quality activity. This week we're going to be doing two different activities in class. One will be related to looking at watershed and water pollution, and the other one will be looking at water collection and data. So to get ready for our two in-class assignments, I have this video in which I will give you some background information and ask you to fill in your notebook so that you are familiar with the vocabulary and with some of the concepts that we'll be working with in class. So pay attention closely, get your notebook ready because you're going to be taking some notes. Okay, so to give you a little bit of information about what you're going to be looking at, I have a quick little presentation for you. So the two activities we're going to be working on, watershed pollution activity, is one in which we will be using a model to describe how there is human impact in the environment and that can affect waterways. So that activity we'll be doing together in class. The other one we'll be doing together in class is the water quality data collection, in which we will have 6 different collection sites that will help us evaluate the health of our local waterways. So here we go. First of all, before we get started, make sure that you, set up your notebook. Copy what you see in the photo of my notebook that I did ahead of time into your notebook. Start with the title up at the top that says Watershed and Water Quality. Underline that. Then move on to filling in this basic outline. And as we go through the video, you can go ahead and fill in the outline. So pause this video and set up your notebook. Now, begin filling in your notebook by sharing 4 signs of clean water and 4 signs of unclean water. What I mean by that is, what do you associate with what clean water looks like, and what do you think unclean water would look like? Take a minute, pause the video, and go ahead and fill that part of your notebook in. Any idea is welcome, so it's anything that you can think of. Now, to describe the first activity for you, this is the watershed pollution activity that we're going to do in class. You might have seen a model that looks something like this. This is called an enviroscape, and it's a plastic model in which you use to demonstrate water flow and activities and instances that may impact water. So we're going to do this part together in class. And what you need to know is basically what a watershed area is before we start. So you can see on the map, I have the Huron River and I have Old Woman Creek shown on a satellite view. Now, both of these waterways are surrounded by land, right? So the land goes right up against the waterways, and then those waterways both filter out into Lake Erie. So a watershed is really that land area that channels any rainfall or snow melt that would be in the area to the creeks and streams and rivers, and eventually it moves out into the larger bodies. Okay, so looking at this satellite view and hearing what I just said about watershed areas, you can fill that section in your notebook, and if you need to, rewind and listen to what I just said. Otherwise, pause the video and fill in that part of your notebook. Next, you need to know about what a riparian zone is. So a riparian zone is the place that's between the land and the rivers and streams. Usually what you see is there's like a lot of vegetation, and the vegetation along those areas really love water. So they're hydrophilic. They love water and they pull up the water and use it very efficiently. This satellite view shows you Old Woman Creek, and you can probably see the riparian zone because in the satellite view, it looks kind of green. You can see trees, and it's just like a buffer zone between the creek and the stuff around it. Now, if you look at the Huron River, there's probably less of a riparian zone that you can see because you have things like marinas and docks and housing developments. You can see there's even like above, or I'm sorry, north of Route 6, you can see that there's the lime plant and different industrial areas. So the riparian zone, or that zone where there is typically a lot of vegetation, can change in an ecosystem. Okay? Now, when we do this activity in class, I'm hoping that you're familiar with what watershed is and riparian zone. Take a minute to pause the video to fill in your notebook for what a riparian zone is. And now let's talk about activity 2. The second day that you're in class with me, we're going to be doing some water collection and looking at the quality of water within the data. So the different collection points will be as follows. First period, we'll walk down during class to Lakefront Park, and we will collect our water samples from the west side of the beach. Second period, we'll walk down to Lakefront Park and collect from the east side of the beach. Now, whether we see a big difference in our data will be interesting. It is kind of the same area, but looking at being on one side of the beach compared to the other, that might have some different data for us. Third period, you will be using the creek that is behind McCormick, and we will walk down to Cleveland Road and look at the section that's by the Heron Cove Apartments. Fourth period, we'll be working at the boat basin in the interior collecting water, and fifth period, we'll be working at the boat basin exterior collecting water. Seventh period, your data collection point will be the Huron River, but where the pier begins. So we'll walk down to that spot. Okay, so the data collection that we're going to be working with is we're going to be taking some notes of like visually what we see around us, anything that would be of concern with the area and what we're noticing as far as maybe like wildlife or traffic, or there could be just some like pollution or anything that you can see around the area that might cause the water quality to be maybe different. We'll be capturing the air temperature, wind direction and speed, and we'll also be looking at the water temperature. As we collect data throughout the year, these numbers obviously will change, and we'll see if there's anything with the water temperature and data that we're collecting. So within the water, we're going to be looking at the pH level, the amount of dissolved oxygen in the water, the amount of nitrates, nitrites, and turbidity. So this is the next part in your notebook where you're going to be trying to figure out what these different things are. So first of all, turbidity. Turbidity is the measure of how much material is really inside the water. So typically water is transparent and light travels very easily through it. But if you have a level of water that has a high turbidity, then that means that there's a lot of suspended particles in the water. And the water might seem murky or brown. Sometimes people actually call it like chocolate milk colored because it has like a brown tint to it if it has different types of materials in it. I have 2 charts there that show you like what level of turbidity looks like. All the way from a low turbidity of like a measurement of 0 to high turbidity, which would be a level of 400. So if you need to pause to write down what turbidity is in your notebook, go ahead. Next up is nitrates and nitrites. So just based on the words, you can tell that it has to do with nitrogen, and you know that nitrogen is an element. It is considered a gas, and it's found in the atmosphere. It's found naturally in foods and in your body and in waste and all kinds of things. And there are healthy levels of nitrogen, and then there are unhealthy levels of nitrogen. So the difference between nitrate and nitrite is just how many atoms of oxygen it has attached to it. Both of these, nitrates and nitrites, you want to have in your water at a healthy level. Sometimes if you have too much like human sewage or livestock manure going into the water, you can get a contamination level that would be considered unhealthy. Also, fertilizers and erosion of like natural rock surfaces can raise the level of nitrates and nitrites. So we don't want to have too high of a level. And the Water Quality Association has deemed that for the United States, the Environmental Protection Agency sets a level of 10 milligrams per liter for nitrates that is safe, and 1 milligram per liter for nitrites that are safe. Now, this is something that when we actually take our water collection data and we look at our method, we'll look at the range and how they've set it up for us. But we're checking the water to see, is there too much nitrates or nitrites in the water to be considered healthy for drinking? Now, I know none of us are going to go down to the river, the boat basin, the lake, and we're not going to scoop out a cup of water and drink it. So we're really looking at it to see, like, is it something unusually high that would cause us some concern? All right, maybe pause the video so you can fill in the level of nitrate and nitrite healthy level. And now to talk a little bit about dissolved oxygen. So there's oxygen in the atmosphere, but there's also oxygen dissolved into water. And you can imagine that oxygen dissolved into water is necessary for fish populations and water plants. Actually, fish populations is what I wanted to say. Water plants are giving off the oxygen. But this range between 0 and 10 is looking at how many parts per million of oxygen atoms are in the water. So you want to see a range that would be healthy for fish and supports an abundant amount of fish population. So you want a certain amount of oxygen into the water. There are different factors that can change the level of oxygen in the water, and we're going to talk about those in class. But in your notebook, go ahead and record what would be a healthy level of dissolved oxygen in the water. And lastly, pH. This is a scale that you've probably heard about ever since maybe 5th or 6th grade. pH is just looking at how acidic or how basic and how basic the water is. We have set up a range between 0 and 14, and 7 is considered a neutral range, which means it's balanced. If it's less than 7, it means that the water has an acidic tone to it. And if it is greater than 7, it means that it has more of a basic tone to it. So if you look at the chart, you can see a couple of different things, a couple of different items on here that would be considered more basic. And it seems logical that your stomach acid would need to be more acidic to break down food particles. That battery acid would be really basic or acidic. And then when you look at the basic end of it, things like ammonia and bleach have more of a basic tone to it. So go ahead and take a minute to record what the healthy level or neutral range of water, fresh water would be. Now, in these activities, really what our goal is as citizen scientists is to monitor the health of the water in a long-term study. And by long-term, we're talking about from end of August to the end of the school year. And as we go through, we can reassess our numbers and look to see if anything has significantly changed. It may mean that in our watershed area, there is something that is impacting the water quality, and we would look at that. And as we collect this data, we're also going to work to develop some infographics that can share the data and our results. So Your notebook should be filled in by now. You will be ready for class whether you are a red or a gray person, so either Tuesday or Wednesday. Be ready to show me your notebook, and then we'll get right into the activities for the week. I'm looking forward to seeing you guys this week. I'm excited for science. Bella is saving up her energy because she's so excited to come visit you and walk down to the beach and explore.